Hello, everyone. Welcome. In the preceding sections, we learned how to search an element in a binary search tree, how to insert an element in a binary search tree, and we learned how to traverse elements in a binary search tree using in order, pre-order, post-order, breadth first, and depth first. And we also designed the BST class. Now let's see how we delete an element from a binary search tree. First, you need to locate the element. If the element is not in the binary search tree, nothing to delete, return false. Now assume we find the element in the binary search tree. This is the node, the current, contains the element to be deleted. Consider two cases. The first case is this. The current node does not have any left child. So this is the case. And the second case is the opposite. The current node has a left child. So let's look at the first case. The current node does not have a left child. So in this case, we're going to delete this current node. So all we need to do is to link the right child of the current to the parent. So like this is the result. So this could be either go to left or right of the parent, depending on the value of the element. So this is the first case and the second case. Now let's look at the example for the first case. So let's suppose we're going to delete this 10. 10 has no left child. So we're going to link 16 with 20 like this. So the parent of this current node is 20. So the right child of this current is 16 linked with 20. All right, here's the second case. Second case, the current is the one we're going to delete. And it has a left child. So we're going to find the largest in the subtree. In the left subtree of the current. And this is the current one is the rightmost node. So you keep going to the right, right. So now, and there's no more to go. So there's nothing to go. And this is the rightmost. We're going to copy the element at this rightmost to current and link left child of rightmost to this parent of rightmost. So like this. And that's all we do. So here's the example. Suppose we're going to delete 20. So 20 has a left child. So the rightmost is 16. We're going to copy 16 to 20 and link 14 with 10. So this is the one. Here's the algorithm. And this one here, we're going to locate the element in the tree. If element E is not found, return. You should return. This should be false. It's incorrect. It is false. All right. So now let current be the node that contains E and parent be the parent of the current. So we're going to consider this two cases here, case 1 and case 2. So finally return true. So there's one element deleted. So there's return true. So if we look at the implementation, so this is the one here. We have the algorithm. So if you go back to the source code, this is the source code. For the delete, And so you're going to consider this two cases. So case 1, and here is case 2. So first thing we do is to locate the element. So this is the while loop, we're going to look at it. So going to the left, the right, and continuously, and until you find it, or if you don't find it. And so this is the current is going to be none. So when this current is none, we're going to return false. All right, so look at this here is the current, okay, that left, if it's none. So we're going to look at the parent. If parent is none, so we're going to assign current that right to the root. Else, so depending on the element value and compare with parent, if it's left, so we're going to assign the current left to parents left. Otherwise, we assign current that right to parents right. So this is case 2. So we're going to find the rightmost and then make the appropriate changes. So finally, I'm going to return true. All right, so here's the test program and using this delete. So we insert some elements in the BST, and then we delete element in the BST and see what is the tree printed. I'm going to print this in order, post order, and pre-order. That is all on this section, deleting elements in a BST. Thank you for watching. See you on the next video.